guys, I was putting a video up talking about the motion of a line, and so here it is. If an object moves along a straight line, its position from an origin at any point time, at any time t can be modeled by the displacement function s of t. So remember, I was telling you have position and displacement; they are the same thing. So for example, you have s of t equals negative 4.9 t squared plus 4.9 t plus 10. Initial position is when t equals 0 or when s of 0 equals 10 meters. The origin is at water level, so the diver is initially diving from a 10-meter high platform, using the example from last time. Okay? Now, the instantaneous rate of change, if you guys recall from class on Friday, is the derivative function. So the derivative of displacement is your velocity function, which is again modeled by this, which is your standard definition of a derivative. Okay, it should look familiar. But then again, of course, that is just the derivative. Now, if velocity is greater than 0, then the object is moving to the right or up. If the velocity is less than 0, the object moves left or down. And lastly, if velocity equals 0, the object is at rest. Again, that's the initial velocity. When the initial velocity is when you plug in 0 for your time, okay? So whenever you're given a particular time, you plug it into your velocity function, and then you decide whether it's going to be one of these three situations, okay? Whether it's at rest, moving left or down, or right or up. So let's take a look at an example. It says a particle moves in a straight line with a displacement of s meters t seconds after leaving a fixed point. The displacement function is given by that example right there. And so we have to basically find the velocity of the particle at any time. Well, that is nothing but just finding our velocity function, which again is just the derivative of our displacement function. So the derivative of s of t is going to be 6t squared minus 42t plus 60, because we apply our power rule here. Now for part B, we have to find the initial position and initial velocity of the particle. Well, remember, initial position is basically when 0 is t. And so we're going to plug in 0 for t into our s function to figure out what our initial position is. And then we're going to plug 0 in to velocity to find our initial velocity. And so then we'll find that our initial position is going to be 3 meters, and our initial velocity is 60 meters per second. Okay, pretty simple. Now, part C, we have to find when the particle is at rest. Well, when the particle is at rest is when our velocity function equals 0. So we have to basically set our velocity function equal to 0. So this function right here would equal 0. And since this is a quadratic, we can solve this by using the quadratic formula. So go ahead and pause this video and use quadratic formula or factoring to find when the particle is at rest. And what time is the particle at rest? Did you come up with 2 seconds and 5 seconds? Hope so. Okay? Because that is when your particle is at rest. Now, to find out if the particle is moving left or right, then we're going to basically have to take some certain values, and we're basically going to have to create a number line and test them. Okay? So this process is real simple. I'm going to go ahead and clear off my board so that way you can see it. Okay? So we're looking at part D. To find out when the particle is moving left or right, we basically have to test some points. Well, we know the particle is at rest at 2. We know the particle is at rest at 5. And we also know that 0 plays a big role as well. Okay? Because think about it. We can't have a negative time, can we? So we're going to start at 0. So basically we create a number line here, and we're going to test to see when the particle is moving left or right, or up or down. Okay? Well, actually, no, it's left and right, good question. So to do this, all we do is we pick certain points that are in between these intervals, okay? So I want to pick 1, 3, and 6, and I'm going to plug them into my velocity function, which again was 6t squared minus 21t plus 60. When I plug them in, I'm trying to figure out, okay, what is the value of my velocity? Because if it is, because if it's greater than 0, then we know it's going to move to the right, and if it's less than 0, it's going to move to the left. Pause this video, plug in 1, 3, and 6 into your velocity function, and determine if it's going to move right or left. Alright, so when you evaluate, you come out that b of 1 was a positive number and b of 6 was a positive number. The numbers themselves actually really don't matter. We're just trying to figure out if they're positive or negative, because if it's positive, then that means it's going to move to the right. If it's negative, that means it's going to move to the left. And again, positive means it moves to the right. So we know that this particle during these time periods are moving these particular, moving left or right. Okay? Now for part E, we have to draw a motion diagram. Now, a motion diagram is actually really easy to draw, okay? All we have to do is we just have to take these points when our particle's at rest to figure out exactly how far we've moved, okay? So, the first thing we're going to need to do is we're going to actually need to figure out, okay, what is our position when our particle is at rest, okay? Our particle was at rest at 2 and 5, remember from part C. So we're going to plug into our position function, S of t, and find our numbers. So we plug in 2, we're going to get 55 meters, and we're going to get 28 meters. Okay? And so we're going to create a new number line and actually draw this model. Okay? Alright? Now if you're wondering why I put down 0 and why I put down 3, well remember, 3 meters, you were there when position was at rest. Okay? So that's why it's important to have 3. And of course you're going to have 0 because, well, you can't have negative meters. So we're going to start at 0. Okay? So now to draw our motion diagram. When t equals 0, you're right there. You're right at the starting point. Okay? And if you recall, from 0 to 2, aren't you moving to the right? From 0 to 2, aren't you moving to the right like we found out in part D? Okay, so we're going to actually draw an arrow going to the right for those 2 seconds. Now, at 2 seconds, I'm at 55 meters. So I'm going to draw my arrow to the right until I get to 55. Okay? So I'm moving to the right for those 2 seconds until 55 meters. Now, between 2 seconds and 5 seconds, I am moving to the left. And at the 5-second mark, I'm at 28 meters. So I need to change directions and go to the left to 28 meters until I get back to rest. And then lastly, I'm moving to the right. Okay, so I'm showing going to the left. Then lastly, I'm moving to the right for after 5 seconds and for the rest of my trip. And so that is how you would draw your motion diagram. Okay?